Okay, so here we are at the last trend that we're going to talk about in the periodic table. It's a trend of electronegativity. And it's sort of the opposite of ionization energy. Remember that ionization energy is the amount of energy to pull an electron away from an atom. Electronegativity is the tendency for an atom to want to attract an electron to itself. Okay? And this is in particular when it is chemically combined with another element. Okay, which is a little bit different than an ion. Okay, so this is when we have two different elements that have formed into a compound, and when they're chemically combined into a compound, the electrons are sort of attracted within that compound. And electronegativity is when an atom really pulls those electrons toward itself. Okay, so based on our trends that we have learned about already, and we know they're based on two different principles, I want you to think to yourself before we talk about it, across or down the group, right? So down the group, remember, the electrons are going to get further and further away from the atom. So think to yourself, is it going to have a high electronegativity or a high attractiveness to electrons, or a low? Okay. Then we have the periodic trend, right? So we go across the period, we're adding nuclear charge. So think to yourself, are we going to have a higher electronegativity or low? Okay, so let's talk about it. Okay, so down a group, the farther the electron is away from the nucleus. Okay, the further away from the nucleus, the less likely you are going to attract electrons, right? So as we go down a group, we're going to have lower and lower electronegativity. Now, remember that metals, they lose electrons, so they typically have low electronegativity, right? They're not going to be attracting electrons to themselves if they're going to be giving electrons up. And as we go across the period, nonmetals tend to gain electrons, right? So they're going to pull electrons to themselves. So they have high electronegativity. So as we go across the period, from left to right, we go from a low electronegativity to a higher electronegativity or attractiveness to electrons when they're in a compound. Okay? So, if we look at the periodic table, what is the most electronegative element? Okay, so if you look, you might think that it would be helium, because helium is the farthest to the right and the highest up. But that answer is incorrect. And the reason why is the in a compound part of the electronegativity. Remember that helium is one of the inert gases, so it is not likely to react, and therefore would not form a compound, and therefore would not have high electronegativity. So actually fluorine, which is the halogen that is highest up in the periodic table, is the one with that is the most electronegative on the periodic table. Okay, so if we look here, and you should note this on your periodic table, electronegativity increases as you go down, or sorry, decreases as you go down the periodic table, and increases as you go to the right, kind of excluding the noble gases because they don't really react and form compounds. So fluorine is essentially the highest up and to the right element on the periodic table, and therefore has the highest electronegativity of all the elements.